Okay, so hello and welcome back. So this is the first, basically, the first part of these videos that we, and here basically we'll talk about DC. So basically DC, of course, there is something here that we need to have an agreement upon, or we need to have we do need to have an agreement about, and that is basically the fact that basically we cannot really define everything exactly as they would be defined, for example, in physics, or in physics probably. And so we are going to have to use some terms without really understanding the meaning of them, at least theoretically, completely. So that is there, but that doesn't mean that we are not going to understand the concept. The concept is usually understood when you solve a couple of problems, and then when you do a couple of experiments, then the concept will be understood. But it would not be it would not be exactly like, for example, how you would understand every detail in physics. It would not be like that. And of course, probably I forgot to tell this in the previous video. And this course is basically more about the practical part, the practical side of electronics, and basically all the theory that we are going to cover here, but just the part of theory that we need, not more than that. And then we will talk more about, and then we will basically spend more time on doing things rather than spending time on theory that we could not actually use in this course. Use practically in this course. So the first thing that we need to understand here is basically, first, DC stands for direct current. Direct current. And as opposed to the concept of DC, we have also AC, which stands for alternating current. Alternating current. And basically DC, the graph of a direct current would be something like this. If this is, for example, if you think of this as your voltage, and if you think of this as time, so if this axis represents voltage and if this axis represents time, then direct current would be something like this. It would be a straight line all across, basically at all times, meaning that, for example, if this is for example V is equal to, I don't know, 10 volts, then at all times the voltage is going to stay at this point, which is 10 volts. It doesn't really matter at what point of time you're looking at your voltage. At any time, basically your voltage is going to be at 10 volts. It's not going to change. So this is DC, direct current. Now the AC is going to be something like this. So suppose that this is time and this is your voltage, then your voltage is going to change over time. usually in a it's going to be usually a sinusoidal wave or something like that. Or sometimes, for example, it's even, for example, a triangular wave or something like that. For example, it could be something like this. But basically, whenever we talk about AC, what is usually meant by AC is basically a sinusoidal wave like this that depends on time, depending on at what time at what point in time you're looking at your voltage. Your voltage is changing over time. Basically, it's going up and down, and so on and so forth. So this would be AC. Now, and we will get into this, I suppose, in the second chapter of this book. In the first chapter, we will talk about DC and all the rules and regulations related to DC in DC circuits. Okay, so basically there are three simple and basic things related to any electrical or electronic circuit. One of them is called the current. One of them has been called the current, which is denoted by the letter I. The other one is called the voltage, which is denoted by capital V. And the other one is called resistance. Is called resistance, which is denoted by R. Okay, and what that means is that, what these are is that basically voltage is also has also been called the potential difference. Potential difference. Now, what these three things really are is basically, suppose that, for example, you want to turn on a light. You want to turn on a light to, for example, suppose at home there is a light in every room, and you turn on a light in order to basically see things clearly when the sun is not there, right? Now, the same concept you can basically, in the same way, for example, you can think of a flashlight, a simple flashlight. So a simple flashlight has a lamp in it and a battery in it. So there is a battery over here. There is a battery over here, or basically a couple of batteries basically connected together, and then those batteries are connected to your lamp. So your lamp is connected to your battery in this way. And then when you have, and of course these paths over here, they represent some wires that you connect from your battery to the two basic poles of your lamp, and then your lamp starts glowing. So this is a battery and this is a lamp. Now, in this simple circuit, there is a battery which creates some voltage. Some voltage or basically some potential difference. And there is a lamp over here that is considered as a resistance in this circuit. This is considered as a resistance in this circuit because, and I'm going to tell you why that's considered as a resistance. Now when you connect a battery to a lamp basically, and the lamp starts glowing, what happens is that basically, you know, probably based on your physics lessons, based on your science lessons at school, well, electrons are just keep moving and moving and moving in this circuit, and technically we say that work is being done, and then as a result of that work being done, this lamp is basically glowing, or the lamp is basically turned on. Now, as a result of those electrons just keep basically moving in this circuit, there is some aspect of electrical and electronic circuits present in this circuit, which is called a current. We say that the current is basically flowing through the circuit. So the current is flowing because there is a battery, and this battery is basically creating some potential difference between these 2 points. Since there is a difference in the potential between these 2 points, electrons keep moving and moving in order to basically compensate for the difference in potential between these 2 points, and that's basically, and that is called a current going through the circuit. This is a voltage and this is a resistance, and your current has to go through some resistance or basically some load, and it basically, your lamp could be, for example, for example, it could be an electric heater with which you boil water, for example. Your resistance could be an electric, for example, motor, with which, for example, you create some sort of mechanical rotation. Your load could be, or your resistance could be some, for example, computer speaker. And as a result of electrons going through that circuit called speaker, then, and through the speaker diaphragm and everything connected to the whole speaker, then you will hear some sound basically, and so on and so forth. So this load is basically, it could be anything that consumes electricity, and usually basically as a result of consuming electricity, you will get a bill at the end of the month that tells you that you owe, for example, $100, $200, $300 at the end of the month, and you have to pay your bill on time. And what is basically, and then basically a current is going through the current is going through your circuit, and this current can go through your circuit because there is a potential difference over here, or there is some voltage over here. This voltage it's basically the energy that can basically get these electrons to move all around the circuit over and over again, so that basically work is done. That's basically the whole story here. Now if you want to talk about this a little bit more, in a more sophisticated way, probably, we say that an electric current, is a flow of electric charge. Is a flow of electric charge, and you know about charges, basically negative and positive. And then whenever you have a battery over here, basically you have this battery over here, you always have the positive pole, you have the negative pole. And so your battery does have these two poles because it is electrically charged, because you have most probably heard of the term charging a battery. You charge a battery, so you basically, if your battery is rechargeable, you connect your battery to some source of electricity, and then your battery becomes charged, meaning that, for example, this pole of the battery becomes more positive, this pole of the battery becomes more negative, and then there is this potential difference between these two poles, because this now you have made this pole more positive, you have made this pole more negative, and that's basically. And then if you connect this battery, for example, to some lamp, the lamp basically starts glowing, and that's a way of, and that is a way to, in order to basically balancing the potential difference between the two poles of your battery. That's basically that. So now, so basically we said that this basically an electric current is a flow of electric charge. Now the electric charge, the electric charge usually consists of negatively charged electrons. Usually consists of negatively charged electrons. Electrons. Now in semiconductors, like for example in the diode or in a transistor or something like that, in semiconductors, there are positive charge carriers. There are also positive charge carriers called holes. That is basically an electric current. Now there are different ways that basically, for example, let's suppose that your lamp is over here, and it is basically, these wires are connected to your lamp. Now the electrons are, of course, in the circuit. So now we need some sort of an electromotive force in order to basically get these electrons to keep moving in the circuit, and then as a result of that, the lamp would start glowing. So there are different ways to do this, meaning there are different ways to create that electromotive force. So there is one way to do that, which is in magnetically. So how you can do that? So basically, if you rotate a wire in if you rotate a wire in a magnetic field, that would create an electric current in the circuit, or in that wire, basically, which is basically called induction. And basically this would be, for example, a generator. For example, in the case of a generator, there you have usually seen that, for example, there is a for example, a wind generator. And what this does is basically the wind generator is basically all of these there is something like a fan, or all of these blades that you put high up in the air, and then there is a shaft over here. That shaft is connected to a generator, and when the wind is blowing, of course, it will keep rotating this wheel over here, or this fan over here. So when the fan starts turning with using the force of the wind, then this shaft, which is connected to a there's a shaft coming out of something like an electric motor. The shaft is connected over here. So when this starts rotating, this shaft starts rotating as well. Now inside this motor, there is something called an stator. There is something called a rotor. The stator is some magnet, an electric is not usually not an electric magnet, but usually a magnet, just a simple magnet all around the housing of this motor. And there is this rotor that in the middle that keeps rotating as a result of the energy basically coming here from the wind. And so on this rotor there is basically many turns of copper wire basically wound on this shaft. And so as a result of that those wires, or you could just imagine just one piece of wire is just rotating inside this magnetic field. And so as a result of that, there's some current is generated inside that wire, or is inducted in that wire. And that's basically what you could connect this circuit over here to this circuit over here, and then your lamp will start glowing. That's basically, for example, a generator, a wind turbine, there is all kinds of turbines like that. There is the wind turbine, there is the turbine that basically you need to basically place in a dam that is rotated using the force of water, and there is all other kinds of things. But basically there is a motor over here that contains a stator and a rotor, and that way you create electricity, or basically a potential difference between 2 points, and that potential difference sends a current through your circuit, and then you will do something with that current, either turning on a lamp or an electric heater, or do whatever it is that you want to do with electricity, basically. Now there is another way to do the same thing, which is basically using chemical processes, and that would be a battery, basically. So chemically you can do the same thing. So a battery is basically, a battery is usually, for example, there is, you can think of a battery as a vessel. You can think of a battery as a vessel, and there are two electrodes in a battery. There is this electrode. There is for example, there is a sheet of metal over here. There is another sheet of metal over here, and inside this vessel there is some sort of solution of, for example, acid or some other solution, and there's all kinds of chemical reactions between the solution, which is, I suppose, called electrolyte, if I'm not mistaken. Electrolyte, something like that. This is some chemical solution, and these are basically two plates of, two metal plates basically immersed inside that solution. And because of all of the chemical laws that you hopefully know about, then one of these metallic basically plates would be called a cathode, for example, and one of them would be called an anode. And I don't really know, probably cathode is the negative, anode is the positive, or something like that, or the other way around. For that, I mean, for the exact information about this system, you would need to read some chemistry. But then at the end of the day, this would be an electromotive force or potential difference that you can just simply connect to a lamp over here, and then your lamp will start glowing. And then after a while, we usually say that the battery is empty now, and you say that the battery is flat. If it's a rechargeable battery, and then you will have to charge your battery, meaning that you basically connect your battery to another generator that has a higher potential difference than the battery. You connect your battery over here, and then the second battery, if you think of this as another battery, this will start charging this battery, and then you can, once the battery is charged, you can then disconnect this one, and then again you can do the same thing. You can connect your battery to a lamp, and then it will start glowing again until the battery is flat, and then you have to recharge it and do the same thing. Usually batteries, I don't know about the new type of batteries these days, but usually a battery used to have, for example, like a car battery or something like that. You could recharge it, for example, for 1,000 times, and then you had to replace the battery, something like that. So this electromotive force, or the potential difference, you can create that chemically as well. So this involves the electrochemical generation of electrons by reaction between chemicals and electrodes. So that is that. There is a couple more ways to do the same thing, which we will go through one by one.